Here are your concentration notes for calculating molarity from the solutions unit. Make sure you click that you've turned in to indicate that you watched this video, as it is an assignment. Molarity is a type of concentration. Now, other types of concentration can involve density. It can involve things like parts per million or parts per billion. But in chemistry, concentration is going to be most often calculated in molarity. Molarity is moles per liter. Moles on top divided by liters in the bottom. It's pronounced molar, and we read things like 3 molar hydrochloric acid. Now you need to make sure that you add this new triangle onto your periodic table. You're going to need that along with the other triangle, grams, molar mass, moles, and perhaps Avogadro's number of particles and moles. But for the most part, these two triangles are the ones we're going to be using. Remember, when you wish to highlight something, when you wish to find the missing variable, you cover it up, and that would indicate taking moles divided by volume gives you molarity. Let's take a look at our first problem. Here we have 5 grams of sugar. Here's this formula for sucrose, or sugar, dissolved in water, and we're going to make 1 liter of solution. How would we find this concentration if we expressed it in molarity? Well, we need to remember that concentration is moles divided by volume. We don't have moles, so we're going to have to find moles, and to do that, we're going to take grams divided by molar mass. Well, what's the molar mass of this compound? Well, find each atom's individual mass off the periodic table. Carbon's 12, hydrogen's 1, oxygen's 16. When you multiply them, you're going to get 342 grams per mole. So, we're going to take 5 grams, which is listed in the problem, molar mass, which we just calculated, and get 0.0146 moles. Notice we have 3 significant digits. When we divide by the volume, which is 1 liter, we're going to get 0.0146 molar. I didn't show that calculation. I figured you could all divide by 1. Let's take a look at another problem. What is the molarity of a 2-liter solution that is made from 14.6 grams of sodium chloride? Start by indicating what's given to you in the problem. In this case, we're going to pick the grams. We don't want grams. We want to cancel it out. So we're going to divide by the molar mass, 58.5 grams for every 1 mole of NaCl. I got that off the periodic table. The next step then, we want to find concentration. So we take moles, which we just calculated, because that's the unit we have left, divided by our volume, in this case 2 liters. And when you do that, you get 0.125 molar sodium chloride. Here we have a hydrochloric acid solution that contains a certain amount of HCl and a certain volume. Again, start with what's given to you, 10 grams divided by the molar mass of hydrochloric acid. We're going to then divide by the volume. When we divide by the volume, remember, we need to have it in liters, so we're going to cancel out milliliters on top, put liters on the bottom. There are 1,000 milliliters in 1 liter, and you get 1.10 molar HCl. Don't forget 3 significant digits, include this significant 0. How many moles? NaCl are in 1.25 liters of 0.330 molar HCl, or NaCl. Again, to find moles, we're going to take concentration times volume. That's this triangle down here. To find moles, concentration times volume. If we plug those values in, here's our concentration, here's our volume, we get our answer. In this case, we want to find moles. Again, moles is going to be concentration times volume. Here's our concentration. Here's our volume. Notice I switched 500 milliliters to 0.5 liters by dividing by 1,000, and I get my answer. I only have two significant digits because my problem started with only two significant digits. A couple more problems here. Again, what's the formula for concentration? Well, if we take a look, concentration is moles divided by volume. I'm given not moles in my problem, I'm given grams, so I'm going to have to find out how many moles I have. Well, the formula for moles is grams divided by molar mass. I substitute that into my equation. I'm then going to have grams divided by the quantity, molar mass, times volume. We've already seen that hydrochloric acid is 36.5. Take the grams divided by the molar mass times the volume, and we get our answer. How many moles are present? Well, again, we're going to use the equation for moles, concentration times volume. I'm given concentration over here. I'm given volume up here. And to calculate that many moles. Now, there's a second part to this question. I asked you for grams. Well, how do we find grams? Again, use your triangle. Grams is molar mass times moles. Molar mass of potassium iodide is 166. Use the moles we just calculated, and you get 95.5 grams potassium iodide. One last question. What volume? Again, volume then is going to be moles divided by concentration. I don't have moles. I have grams. So I'm going to need to find moles. Grams divided by molar mass. I'm given 32.5 grams in the problem. I looked at my periodic table and added H plus Br and got 80.9. I got that many moles. Now remember, we're going to plug that into this question mark up here. Our moles divided by our volume gives us the liters of solution that we would need. I hope you learned a lot from this. There are lots of practice problems to do. Don't forget to check that you've watched this by turning in the assignment. Thank you.